Good afternoon to all of you, and welcome to the January Smart Grid Educational Series webinar. I am your moderator and your speaker today. My name is Irfan Ibrahim, and I am the Strategic Innovations Director at GridStar, which is a DOE-funded project at the Philadelphia Navy Yard and managed by Penn State University. I have also accepted the position for Senior Consultant at Compass Management Group. This is a strategy consulting company that has been put together by Andres Carvalho, who is a former CIO of Austin Energy. And we will be at Distributech next week. Andres will be at the booth for Proximetry, and I'll be operating from the booth of Citer. I am also the founder and CEO of the Bid Bazaar, and that is the consulting company that I formed some 12 years ago, and I am using that platform to do these various consulting jobs. And I also lead the energy practice for Citer Corporation, which is a large integrator that serves the federal government as well as some private enterprise. So with that background, what I wanted to do was talk today about smart grid maintenance programs and service levels. We've been talking a lot about architecture and cybersecurity and network management and protocols, but now we are at that stage in the evolution of smart grid where a lot of infrastructure has been deployed. And it is very important for us at this point to think very carefully about how we're going to maintain all of this infrastructure. And so the presentation today is about some of the challenges that the electric sector is facing now, and then get into the nuts and bolts, if you may, of service levels and maintenance programs. And I'll share with you some golden nuggets or best practices which I think that if they became an industry standard will help reduce a lot of contention in post-implementation, make it more cost efficient, as well as motivate the workforce to serve in these capacities. So our agenda today starts out with a description of what I call the impending perfect storm in the electric sector, and I will get into the various attributes of this perfect storm, and then explain why it's really important to talk about the cost management of maintenance programs to avoid a lot of the negative effects of this impending perfect storm. The next topic I'll talk about is how does an organization make a decision whether to make maintenance in-house or whether to buy it from the vendors or from third-party providers. Moving along, then I will talk about a cost-plus model for pricing maintenance, and I will distinguish it from the current programs that are out there that a lot of third-party service providers and vendors provide, where they talk about maintenance as a percentage of hardware and software costs. And I'll show you some of the pros and cons of that approach, and then suggest a cost-plus model that I have developed some 20 years ago, and the rules or the rules of thumb in that model can apply to this day in smart grid. And then I will talk a little bit about service level agreements. Why are they important, and why is it important to have very precise language in service level agreements? Then I will move on to talk about what kind of culture should you have for collecting data. A lot of organizations collect a lot of data. There'll be terabytes and petabytes, but they're not going to be all kept in a way that can be easily retrievable. So I'll talk about some ways, some best practices in how data can be collected. Then I'll get into decision trees and how they are important for doing incident response and how that helps contain some of the costs and also helps in training the workforce. 7x24 operations is an important part of the electric sector. You want to make sure that electricity is available round the clock. So network operations centers of utilities and energy service companies by default have to be open 24 hours a day. And I will talk a little bit about how you go about building a workforce for a 7x24 operation. Then I'll get into the nuts and bolts of smart grid technology maintenance. I'll talk about the different service levels. I'll talk about things like warranties and guarantees and software support and spare in the air and various other terms. Then I will get into some of the standard rules that are out there for hardware and software maintenance. You have to have a good idea of what is expected of you if you're delivering a service to a utility, and similarly, if you are the maintenance or service arm of the utility, how do you support the other business organizations within the enterprise? And then I will talk a little bit about the workforce training and why that is a critical component of providing maintenance programs. And then I will talk a little bit about the GridStar initiative that I'm leading at Penn State, being the liaison, if you may, to the industry. And I'll explain how some of the strategic thrust areas of GridStar can be helpful in developing service programs for the utility industry. And then finally, there will be a Q&A opportunity and a discussion. So that is the agenda. It's a pretty full agenda, but I only have like 17 slides, but they're pretty intense. So I apologize in advance for not having graphics in this PowerPoint presentation, but I have seen one too many cartoons with the guy, perspiring as he's typing away, and those are the kind of artwork that I've seen out there in presentations about service levels. So I will try to create a more artistic presentation later, but I thought it would be important to provide you some sober and serious information which can help you in your respective jobs. So first, let's talk about this impending perfect storm in the electric sector. We're seeing reduction in meter collections. There are several reasons for that, but two of the major reasons are that a lot of the energy efficiency schemes that were deployed in 2007, 8, 9, and onwards have started taking effect, and the customers are consuming less electricity as a result of those energy efficiency schemes. There is a slowdown in the economy as far as energy consumption is concerned. While Dow Jones and S&P, all of those figures seem to show an uptick, but manufacturing sector is lagging, and generally, if you look in both commercial and industrial sector, you see a significant drop in the consumption of electricity. Some of it has to do with energy efficiency, but some of it has to do with the fact that the economy growing has not had as much of an effect in terms of energy consumption. Then the next item is that there is a lot of pressure to shut off coal and nuclear power plants. So as they're reaching end of life, a lot of times they're not being given the right to put a new unit there or to refurbish it in some way, and they're being either mothballed or being shut down completely. And what that does is that you start losing your low-cost electricity source. If you look in the energy mix, hydro, coal, and nuclear have the lowest dollars per kilowatt hour associated with it if you account for the total cost of ownership over the life of a plant. So here we have a situation where we're losing two critical items that help us get electricity at a low unit price. At the same time, we're seeing more and more integration of non-hydro renewable energy. That's another way of saying solar and wind and biomass and others. So what's happening is that the unit cost of those is going up. And the reason why is because a lot of times they're produced on smaller scales, and there is also the need for electric storage to offset the intermittent aspect, especially of solar and wind, and that has a premium price associated with it. So when you look at it overall, don't just look at the solar panel or just the wind turbine, but look at the overall infrastructure cost for upgrading to integrate renewable energy on the grid. It is coming at a premium dollar per kilowatt hour. So we are losing the low dollar per kilowatt hour sources, and we're gaining high. So think of this as part of that perfect storm. Then we have a lot of initiatives for having RPS targets that are leading to what we'd call net zero homes and commercial buildings. So on the whole, you're not consuming any net electricity from the utility. So whatever you are taking from it, you are providing it later when you have excess energy. And by doing that, what is happening is that the distribution companies have fewer and fewer kilowatt hours over which to spread their infrastructure costs, which is typically fixed, or a big part of it is fixed, the variable part is smaller. So as a result of that, the distribution companies are feeling the pinch. If they try to pass on that infrastructure cost as a higher surcharge dollar per kilowatt hour, then they have to deal with the PUCs. And that's my next item, that in this environment with the economy relatively slow, especially for a lot of the lower segment, the lower economic segment of the population, a lot of consumer advocacy groups are lobbying PUCs not to raise the rates. And then you have the skilled workforce that is on the verge of retirement, and many utilities, I have shared with you figures in the past. The most ominous one is like 62% of the utility workforce will retire by 2020. And what that means is that higher wage people will have to come in because we have to incent them to work in the electric sector out of college, and they are not as skilled. They don't have the practical experience, so they still have to be trained. So that's another issue. And then, of course, transportation, fuel, and utility labor costs are rising. So if you put all of these things together, this is why I call it the perfect storm. And this is making utility management people and their integrators and their vendors and consultants, everyone scratch their head to try to figure out how to mitigate all of these issues simultaneously. So this is a very good backdrop for justifying why you need to have a robust maintenance program in order to reduce your operating costs to be able to handle all of these things that are coming at the utility at the same time. How do we decide whether we want to buy maintenance or whether we want to make it in-house? Some of the pros of doing in-house maintenance, and the reason why you see a lot of utilities having large workforces maintaining it, is that consistent quality. You have a proper training program, you teach your field service technicians that they have to perform jobs at a certain level, and you have that total quality management program in place, so you can have that consistent quality because their performance and their bonuses and everything can depend on that. The next thing is that when you have employees with a fixed labor, you are much more financially flexible. You can have them, even with some overtime and stuff, deal with extenuating circumstances. Much harder to do when you have outsourcers that will charge time and materials in those types of situations. Then, because you have the force, you know where they are, you can incent them to go and take care of things faster and sooner. And then, of course, when you have as employees, they have to fill certain forms out. They have to show certain transparency. So there's much more accountability when you have your own staff. Now, at the same time, there are some cons where outsourcing may be a better thing. One is that you have to always train these people. Technologies are moving very rapidly. The new technologies are being put in. So as an organization, if everyone is an employee, you have to constantly train these people, and that costs time and money. And then you may train them, and then they may get a better job. We're making 10, 15, 20% more money somewhere else, and you lose them. So now all that investment you made in them goes away. And then in some of the smaller organizations, I would say this applies more to munis and co-ops that have smaller enterprises, that you find that the cost of labor is high. So, in other words, you're not enjoying the economies of scale, and so it's much harder to maintain an in-house capability for a much smaller infrastructure. And then you don't know much about what's going on out there. One of the nice things about outsourcing is that the outsourcer is involved with multiple clients. So whatever they learn in one place, they can sanitize it, take away the confidential information, and bring some of those lessons learned to the other organization. When you only have your own employees working and fixing things, you just have the knowledge base based on that experience. So those are some of the cons, if you may, for doing things in-house. But the conclusion from this analysis is that every organization needs to make their own decision, whether they're going to keep certain functions in-house or whether they'll outsource it to third-party service providers or the vendors who are providing the hardware. It's not easy to just prescribe universally and say it's better for you to outsource or it's better for you to keep it in-house. Even though studies have shown that outsourcing can typically save 20 to 25%. But what does that saving really get you if you don't have high availability of electricity for your customers? What is the opportunity cost for dropping in availability? So that's why this is not a very simple decision. And every utility has to look at the access to labor, the wage rates, and also the service territory to make decisions about this. The next item is, how do you develop a cost-plus model for pricing maintenance? Notice I prefer this to the method where you just arbitrarily decide what the maintenance pricing will be as a percentage of the hardware and software costs. And I'm addressing now vendors, I'm addressing third-party service providers and utilities when I make this observation. Because many times, a utility may have a maintenance department that is its own profit and loss center. It has to provide services to other departments. So these rules apply even within a utility, even if it's in-house with salaried employees, because you have to decide when you're going to add additional employees. You have to decide, when you want to train them. You have to also decide where to keep them. So this addresses all three parties. So the first thing is that if you want to maintain something, you got to know what it is that you're maintaining. Quite often, enterprises have very little clue of what's out there. And that's not very easy to do. It's not just like doing an SNMP walk and just discovering a bunch of nodes like in an enterprise network. We're talking about legacy equipment and modern equipment, and many of the utilities that have received stimulus funding are now going through that exercise after they've implemented smart grid to write service description documents. Because without that, it's very hard to maintain. You don't know what is out there. So creating a proper inventory of all hardware and software is important. The next thing is that you have to estimate how much labor is required to maintain each piece of infrastructure. Now, there's some ways to do this. There is vendor information. directly from the vendor as well as from industry experience, which people write in blogs and other places. And you can figure out from that what kind of reliability do these devices have? How often do they break? You can verify some of that by running actuarial models on your trouble ticket system. That's exactly what I did for Pacific Bell 18 years ago. I ran SQL queries on 1,100 trouble tickets, and I could figure out what was the mean time to failure for a Cisco router, a switch, a Bay Networks, a 3Com, and pretty soon I knew how often they were failing, how long it took to fix it, what was the fully loaded labor rate, and I could start costing each year what it would require to maintain each one of those pieces of equipment. And that had never been done in Pacific Bell when I did that. People were just doing what I would call a swag when it came to pricing maintenance. And that's why they didn't know whether they were making money or they were losing money. And here we were the network integration group, where our whole reason to be was to have a profitable maintenance program. So I cannot emphasize that enough, to create that bottoms-up approach to pricing. Estimate the labor on each piece of equipment, figure out what your fully loaded labor rate is. Don't go with the salary. You have to use the fully loaded labor rate. That includes the electricity, the building costs, the interest on any loans the company has taken, all of that. And the CFO and controller can help you with that in your organization. And once you've figured all of that out, then you can create this bottoms-up cost model for each piece of equipment, hardware and software. Then you have to add some nominal profit to this. We are not running a nonprofit organization. This is not a charity. And so you have to include some profit for growth. If you don't do this, you will remain stagnant, or you may actually start going down because of inflation. And so you should not apologize for that profit. And I also would recommend to the utilities that are writing the RFPs to please make sure that these considerations are done and that those RFPs have behind them the budget to support a healthy maintenance program. Because what will end up happening is that the vendor or service provider, in trying to win the deal, will create shortcuts just to win the deal. And then once the deal is done and the utility is now thinking, okay, they're going to get a certain level of support, that's when the service provider and the vendor will start explaining it away and trying to sell you stuff on time and materials. So that creates a lot of contention. It's much better to budget for it in the RFP, and then when it's awarded, to make sure that the vendor and or the third-party service provider is adequately budgeting for maintenance and is showing that in some analytical way. It's very, very important to avoid contention after the implementation is done. And then once you have this cost-plus model, provide it to the marketing department. They don't know how much we should charge. They're going to rely on the technical people. So once they have this bottoms-up approach and they get the math, they will be able to create the collateral to offer your services, and the pie size will increase. And that's the key thing here. The size of the pie has to increase. Now let me show you some of the pros and cons of charging maintenance as a percentage of hardware and software costs. Well, it's easy to calculate. Typically, when you have software warranties, they're around 5% of the software price, all the way to 25% for the high-end 7x24 on-site maintenance with 4-hour response, or in some cases even 2-hour response if there are some very mission-critical applications. So companies do this. It's a very common industry standard, and this is not limited to the electric sector. You can see that in telecom, financial services, and other areas. It's easy to market. You just tell someone, oh, installation is 10% and maintenance is 15%, and they just budget it quickly. They can calculate it on the back of an envelope. And whenever there are new products and services, then it's very, very easy to communicate that and get the new pricing for the new piece of equipment. But look at the cons of this. One is that it never really captures the true cost of maintenance. Since when did we have a rule that says that just because a piece of device costs $100,000, it will cost $10,000 or $15,000 to maintain it? Every device is different. Depending on the degrees of freedom it has, the amount of configuration it needs, the cost of maintaining it can be enormous. So just arbitrarily putting a percentage of the hardware and software cost does not address the true cost. Then what happens? You have high-end devices where the percentage is a lot of money, and they are now subsidizing the maintenance that you're collecting for low-value items. But what happens is the low-value items are the ones that require a lot of fixing. So now you're doing this cross-subsidization, and that is not healthy, because now you have to always worry about what the mix of high-value and low-value items are going to be in your service delivery in order to make a profit. If you had built the cost-plus model, you would make money on every device you support. And then it doesn't allow the maintenance department, let's say you're in a utility and it's in-house, if you don't have a cost-plus model and you don't know that you're making a profit, next you're going to be looking for subsidies from other departments of the enterprise in order to keep afloat. Sometimes you'll make money, sometimes you will lose money. But if you follow the cost-plus model, you always make money. And then some vendors will do this. They will provide you maintenance at a low price, but then they'll jack up the hardware and software price, the list price, in order to have the margins available for the cross-subsidy. So if you look at this very carefully, while you're getting ease from a mathematics perspective, it does not capture your costs. It doesn't allow you to scale up or down or across the various products, and it forces you to add margins and other things that don't belong. Now let's talk about the service level agreements. Service level agreements are written, legally binding documents. And I would recommend that any time two parties are involved where one is providing service to the other, to write it down. Have very precise language of exactly what are you going to do in each of the major circumstances so that the expectation is clear. Quite often, if you go and look at the contention that exists in the industry and get to the bottom of it, you will find some person who's irate because the service that they were expecting from someone else was not delivered. Why were they expecting something that the other party was not delivering? Because it was not written, it was just assumed. Well, there are laws where guarantees are implied in certain states of the United States, for products to have a certain quality. But when it comes to maintenance and service, transparency is the main essence. It is really important to have complete transparency, very clear cut, that this is the process we'll follow. We'll open a trouble ticket. We'll do a certain amount of troubleshooting remotely. And then at some point, we'll make a decision that we need to come on site. And then we will come. And this is how much time it will take us to get there. And this is how much time we'll give you in a year to fix the problem. And if it is more than that, we'll charge you a certain fee on an hourly basis. All of that has to be agreed with up front before the first electron flows. Because if you don't do that, all you're going to end up with is contention, and then guess what? You're going to drop that service provider and go to the next one. Well, if you don't have an SLA with them, you're going to have that same problem again. So quite often, when customers say, our service provider is terrible, what they're really saying is that we don't have a good way of communicating with them. We don't have a good way of setting realistic expectations. So I would strongly encourage for people on both sides of this equation to get SLAs, very precise SLAs, and make it part of the negotiation process, make it part of the sales process. And then in the SLA, there should be this high-level methodology of how you deliver the service. And when you sign and make it legally binding, let there be some training so that people understand the various tenets of the SLA, and then they go off and do their day-to-day jobs. And you will find that a lot of that contention that I just mentioned would go away with that precise language. And I would encourage utilities that provide in-house services, to consider themselves as their own profit and loss center, have that autonomy, and show the transparency to the other departments that you're delivering that service. Because that's how you justify to your CFO to add budget. That is how you help the various departments do their jobs better. So the more autonomy there is in a department and transparency, the more is the ability to grow in a managed way. This slide is something that everyone kind of knows, but doesn't really talk about. When I talk about documenting, it is so important. Quite often, you're going to find a lot of data tools that have this option of putting data in a flat ASCII file. ASCII file is like an ocean, and data is like drops of water in an ocean. You put it there, you might as well say goodbye in multiple languages to that data. Because who's got the time to go through these tedious, verbose files looking for relevant information? So just like, how do you distinguish, for instance, between a person who's got a good memory and a bad memory? Ask anyone who's got a good memory. They will tell you that at the time when data is coming in, they make decisions about how to remember it. They put the appropriate cues on the incremental piece of information they're receiving. And then it's very easy for them to retrieve it because they remember it a certain way and they remember that way. That is not a flat ASCII file. That would be an object database. That would be a hierarchical structure of data that has a set of rules by which you get to the data element that you need. And I would recommend that all operational data be parsed properly at the time when it is being gathered, because that is how you're going to distinguish between having reams and reams of data from which you cannot produce reports and data that is intelligent from which you can quickly get what we would call actionable intelligence. And this is very, very critical when you are maintaining infrastructure and when you're doing troubleshooting. This will help reduce the cost, because anyone who has to sit for hours trying to figure something out from flat data, that's cost to you. So try to minimize that. Part of that is also creating configuration data. Know how the various parts of your infrastructure are connected electrically and logically. This is not something that just happens with auto discovery, as I mentioned earlier. Some of it requires field service technicians going and creating detailed logs as they go to the various pieces of infrastructure and observe. They create that infrastructure for you in diagrams. Those diagrams are brought and you can create the hierarchical architecture which you will have so that when you are receiving events on your real-time management system, when you combine that with configurational data, it will quickly help you figure out where there is a fault, for instance, and how to recover from it, because you'll have both the configuration information and the event data. If you just had a bunch of flat files with this data without the proper parsing, without the configurational intelligence, you could have multiple alarms and not know that they're all being generated from a single event because you don't have the logical intelligence. So this is very, very important in reducing the mean time to repair. And also continue to apply big data management analytics on the data periodically. And this is, why is this important? Because if you do, you can be proactive. This is almost like dental flossing in the electric sector. You want to avoid gum disease and loss of teeth? What do? You floss. What do you do here? You keep looking for that smoking gun. Because wherever there is that smoking gun, then there's a guilty party involved somewhere there. Or wherever there's smoke in a forest, there's usually a fire somewhere. Why is this important? Utilities usually have certain scheduled downtimes. A certain period of time when they bring the power plant, for instance, down, or a particular substation or a particular transmission substation, whatever the piece of infrastructure is, for servicing. If they knew from doing analytics on big data throughout the period between the downtimes, they would know which things to proactively maintain to avoid disruption in between the service downtimes. And having this big data management analytics capability and looking at the logs and figuring out, okay, now I don't think this piece of infrastructure is going to last till the next downtime. Let me take care of it now while I am down now. So what that does is it avoids unanticipated outages. I mean, yes, there will always be unanticipated outages from ice storms and hurricanes and all of that. That's different. I'm talking about routine system failures. So if we take care of that, you will understand then how quickly you can bring a system back up, because you would have a very good plan of maintaining it during the downtime. Also, during hurricanes and ice storms and blizzards and other things, you're going to find that having this data allows you to quickly figure out where the issues are. Maybe you saw high levels of corrosion in the last read, and you know that with this weather, this must have really caused a problem. Let's go swap them out. So having this intelligence helps you in both the natural disaster situations as well as routine system failures. Let's talk about incident response and how decision trees can help. The difference between a well-oiled network operations center and one that does things haphazardly is the presence or absence of decision tree models. There are certain things, if you run a network operations center, you will know, that repeat every day. And there is a certain percentage of the infrastructure that will fail every day. There will be a certain number of tickets depending on how many nodes you're managing every day. Now, they fall in certain categories, broad categories. There may be system failures, there may be configurational issues, there may be flooding, all kinds of things can happen. So what you want to do is start a process of elimination by checking and testing things, and those are the limbs of the decision tree. And if you develop those for the various scenarios of failures, what you could do is train the tier 1 level support on those decision trees so they can take care of a lot of the routine outages themselves without having to escalate it to a tier 2 or tier 3 level support. So that helps reduce the cost, it helps reduce the mean time to repair, and it helps the SAIDI and SAIFI numbers. So having those decision trees is very important, and it's an evolutionary process. It will constantly, you will add more limbs to the tree as you add more ways of fixing a problem. Now, once you've trained the tier 1 support, make sure that in the decision tree, there's a very clear handoff point between the tier 1 and the tier 2, 3 level. Quite often, tier 1 people want to be macho. They want to prove to their superiors that they can handle it. And guess what? You have a poorly trained individual trying to solve a complicated problem, takes much longer than the tier 2, 3 support person could have done. But if you establish a clear handoff point and tell the tier 1 person, at this point you need to transfer from your level to the next level, then they don't feel like their job depends on it. They feel like they're doing their job by handing it off. So a lot of this machismo goes away and the problem is mitigated faster, sooner. Quite often we find that if you just get the egos out of the network operations center, you will solve problems a lot faster. And decision trees help make egos irrelevant. If you want to do your job, follow this decision tree, get to this point, and pass it on. The same thing I would say for the Tier 2, Tier 3 people. This is not a master's degree or a PhD program where you have to write a dissertation. This is a job you're doing. So there has to be a point where you bring in the big guns. Who are the big guns? The vendors and the service providers. So have a clear handoff point after which you say, I am frustrated, I cannot fix this problem, I need to pass it on. We lose a lot of time in network operations centers because senior people feel like they know it all, they can fix it all. This is a big problem, and we need to address this by having very clear-cut handoff points to outside people. And then you add these additional limbs as you develop new techniques for first-time events, or if you can help reduce the time for previous events. You know, when you sit down and you analyze them as a team, you say, oh, I could have jumped these 3-4 steps, I can go directly to this step. And when you decide as a team that next time you'll do that, modify the decision tree. This is not gospel. This is an evolutionary document developed for having consensus-based troubleshooting. And then when you have these one-off situations, which you cannot put on a decision tree, then you write some descriptive material, but make sure all the tags are there to quickly pull information out of that one-off type documentation. We have some basic rules for 7x24 operations planning. There are 168 hours in a week. On planet Earth, that's the deal. We have a requirement for employee safety that when the rest of the office is out, make sure that there are at least 2 people there in case of medical emergencies or whatever the issue may be, safety. And so you need 2 people for 14 hours. So if you add it up, we're looking at about 266 hours of labor time minimum for 7x24. Then if you have full-time is 40 hours, let's say 38 hours is effective time, the rest is holidays, sick, and other things. So you need a minimum of 7 people at Tier 1 level to support a 7x24 operations. You cannot do it with 5. You cannot do it with 3. There are just some legal requirements. You don't want to run a network operations center on overtime. That is just not good karma. People may get paid overtime to do some secondary and tertiary activities, and you can pay them to do that. But mission-critical stuff should be done by people who are alert, focused, and in good health, because a lot rides on this. If you don't do maintenance correctly, or if you're not dealing with events, the outages can have a huge financial effect. So while someone may think, oh, you know, I'm being really smart by not hiring an additional person and just giving overtime because I don't have to deal with the overhead of the next person, not a smart idea. Because if they were asleep or they were tired because they're working overtime in mission critical, you don't do that with airplanes and pilots. Why would you want to do that with Network Operations Center? So be generous here, put the right number of people. And then there is a ratio of 1 to 3. So if you have 3 Tier 1 people, make sure that you have 1 Tier 2, 3 level person to support them. Don't burden 1 Tier 2, 3 person with the work of 5 or 7 Tier 1 people. Not a good scaling law, because what happens then is they get backlogged, then the Tier 1 guy cannot do anything. So then they try to tell the customer creative stories about what's happening, and it's just not good for business. And then also what it does is if you have a 24/7 operation, the good thing here is that you can move some of the work to the second Tier 2, 3 person. And they can alternate. Maybe one of them is on vacation, doesn't want to be disturbed. So you have a backup with the 7x24. If you had a 5-to-1 ratio and you only had 1 Tier 2, 3 level person and that person was sick or on vacation, you're out of commission. Now, suddenly, the tier 1 person has to keep calling the vendor and the third-party service provider for their routine day-to-day stuff. Not a good idea. So I am recommending these rules not just for the utility that's managing their assets, but also to service providers and vendors who are maintaining such facilities. This is just good practice. And this is the result of having worked 2 years in a network operations center with 24/7/365 responsibility, managing 5,000 sites, managing the Western backbone of the internet, and personally having opened 1,100 trouble tickets. I can show you my battle scars if you come to DistribuTech, but I will tell you that these rules helped me go from tier 1 support. That's my job. That was my job when I joined in March of 1995. And by January of 1996, like 9 months later, I was the supervisor of the entire network operations center. And the reason was because I figured these things out. And when I communicated it to the management, they said, "Do you think you can run this?" I said, "Of course I can run it." And so I did. And I never knew that, 18, 19 years ago, that one day I'll be sitting here explaining the virtues of 7x24 operations and best practices. But I'll tell you, this is one area where Moore's law doesn't work, where economies of scale don't work. None of that works. What works is sound reasoning. Human beings behave in certain ways. You have to understand their nature, and then you develop systems around them to accommodate their characteristics. And that's what this is. This is like a distillation of 2 years and a lot of heartaches. Let's talk about the nuts and bolts of smart grid technology maintenance. You have to understand that there is a slight difference between guarantee and warranty. So guarantee is what happens when a vendor says, in this period of time, if the product is faulty, I'll replace it or I will give you a refund. Warranty doesn't return the product and give you a refund, but says I will either replace it with the one that works or I will repair it. So that's the slight difference between guarantee and warranty. And then hardware and software warranties, manufacturers provide them, and then there are third-party extended warranty. Anyone who has purchased a car or a piece of electronic equipment knows that these things are there for hardware and software. But there are certain exceptions for gross negligence and for improper use, and that's how they protect themselves from just having unnecessary returns from customers. And the same thing is the case in the electric sector. Telephone support is a service that a vendor or a third-party service provider will offer. The utilities will also offer it from their NOC to other business units. And this type of telephone support is usually occurring with a bank of telephones and people sitting with trouble ticket systems and with some real-time monitoring. So they provide this telephone support. A lot of the warranty programs also come with telephone support, and an industry standard is you get a call back within 60 minutes if they didn't pick up the phone. You have spare in the air type programs. These are like silos where equipment is kept so that you can quickly dispatch to the place where it's needed. And then these are typically the 3 types of maintenance levels that are available on site. Why is on-site maintenance important? Because quite often a client may not have the workforce to take it themselves to the site and fix it. So they outsource it. Now, whether the outsourcing is occurring internally within the utility or to a third party or to a vendor, they provide this on-site maintenance to provide assurance that within a certain period of time, the equipment will arrive, it'll have the right configuration, it will go in, and you'll fix the problem. So these are 3 levels. The next business day is another way of saying 8-hour response, and Monday through Friday, 9 to 5, at the moment the day starts, 8 hours means the next day. But there is also an expanded Monday through Friday, 7 to 7 kind of facility. This is for some customers that may have longer work hours or they're open for service till later. A lot of retail and other places are like this. So you give them an 8-hour response. 8 hours means that, by 11 o'clock, if they did not send someone, then they can send it as soon as the next day. And then 7 by 24, 4-hour response is, top of the line. This is the S class. 2-hour response is like very, very mission-critical type customers, a lot of healthcare and government, where there are very mission-critical things involving national security, may even demand 2 hours. All of this is written usually in RFPs of what level of service they're requiring. I'm showing this to you to show you that there are some standards, and that when you are responding to an RFP, make sure that you understand what is asked of you by your client and then price it accordingly. And then time and materials is exactly as it is. Whenever something isn't covered within on-site maintenance contracts, then you extend to time and materials and you charge until the problem is resolved. Some of the standard rules for hardware and software maintenance, I mentioned about product guarantee and product warranty already. And I also mentioned that warranties and guarantees usually come with a complimentary tech support. Anyone who has purchased a computer knows that whether you have a Dell, HP, or whatever, you can get telephone support from them. For the operating system, you can call Microsoft, and similarly for Apple, you'll call Apple. And then parts replacement usually occurs with what's called a Return Merchandise Authorization Number, or RMA number. And what that does is it avoids you having to pay a restocking fee if you just send it. If you get an RMA number from the vendor and you put it and you ship it back, typically they expect you to pay for the cost of shipping to the vendor, and the vendor covers the cost of sending the replacement on their own expense. So these are some of the rules that you should be aware of. And then I explained what on-site, the 3 levels of on-site are. And the key thing here is that you decide your maintenance level based on the level of criticality of the systems you're maintaining. So if you need real-time response, you need high uptime, you would have to go for a 7 by 24, because at night you can't afford to have something out for 7 or 8 hours, or in the case of overnight, it could be as much as 12 to 16 hours. So you don't want to go there. But if you have something that is not so mission critical, you don't want to pay premium dollars for it, you go for the lower level of maintenance. Key thing here to understand is that there is a service level for each type of business. But understanding what the terms and conditions are is critical to having a happy experience. Spare in the air programs, these things are created to distribute the equipment out. Quite often, the transportation of the equipment is inconvenient, if you have to go over long distances. So vendors and third-party service providers have a tendency of putting equipment in different silos. There are storage spaces. And what a service technician can do is they can come from their home to the silo, pick it up, and then head over to the customer site. In some cases, if those silos are manned, they could actually ship it and have the service technician just show up at the site. So both of those possibilities are there. And then on-site maintenance program time improves considerably when you have spare in the air, because the service technician is not burdened by the equipment anymore. They can maybe get to the site faster. And also, when time and materials, what happens is when you have a certain number of hours that you're given of on-site per year. And if you exceed that because you've been asking the person to come often, you can get into what's called time and materials mode, and any subsequent service that's done on-site will be charged based on the time and the additional material that is needed. Now I'm going to talk a little bit about workforce training and why that is important. It's obvious that power systems are getting more and more complex, and there are communication and cybersecurity requirements, much more granular control, and you naturally need more monitoring and more support. So if the workforce is not adequately trained, there's going to be a lot of guessing games going on and delays, and eventually expensive labor has to be brought in to fix the problem. So if you have the proper decision trees and you train them on the decision trees so that they can take care of the routine matters and keep training them on the new technologies so they understand, they get more situational awareness, then they will be more effective in the maintenance programs. They'll reduce the mean time to repair, the cost of the maintenance programs will come down, making the service provider organization more competitive in the market. And that is the key to sustained competitive advantage. Don't stop learning. Keep educating your workforce, keep streamlining the processes. Because of that impending perfect storm I'm talking about in the electric sector, the one who's lax, the one who is spending money, a lot of money without proper due diligence is not going to remain in the game for very long. I'm talking about even service providers in-house in utilities will be shut down and they'll go to some outsourcer that's more cost-effective. So the key thing is not the budget. The key thing is transparency and accountability. Make sure that you can prove to your bosses and to the customer that what you're charging is justifiable because of the amount of work that is involved. And the work that's involved is the most efficient work that you can do to resolve a problem. That's key. Transparency, accountability, and innovation. So for that, workforce training is like bread and butter for keeping viable maintenance programs. And the training is not just PowerPoint presentations. I often see people say, oh yeah, I got trained. I sat for 8 hours and watched this guy tell me about all these systems. Well, where were you? I was in a class. What were you doing? I was sitting in the back and they were just flipping slides. Well, you're not going to get the kind of education that is necessary to resolve real problems by just watching a PowerPoint presentation. It's good to get a perspective, just like I'm giving you a perspective on maintenance by sharing some slides with you. But if you take my lessons learned and my advice and go apply it, you're going to find there's another level of detail below this in each of these areas that I've talked about. But you get the game plan, if you may, from such a presentation. The same thing with workforce training. Slides, PowerPoint presentations, in-class stuff is good to put things in perspective, but then you have to get your self-paced tutorials where you can do little exercises and practice, and you also have to have an apprentice program. Look, you know, for centuries we have learned arts, various music and painting and all kinds of things, even basket weaving and carpet weaving through apprentice programs. Why do we think that just because we have computers now and high-speed connections and all of that, that we can somehow do away with apprentice programs? Not the case. And I would really recommend, especially for the new workforce that's coming into your organizations, inculcate in them the value for apprenticeship. I'm not seeing this in the millennium generation. They think they can pull it off on their own. And I have to tell you that all this texting and emailing and living off of a screen is creating this culture where they feel hesitant to go and learn from someone who knows things really well. So I would encourage you to make apprenticeship as part of their career development plan and that they learn from the people who are experienced. Now, many times, these people who are more senior in the organization may not know about the new technologies, and the new generation may know about all the gizmos. But the rules of thumb about electrical systems, about what works with Ohm's law and Kirchhoff's law and how a substation works, that is not just limited to a lot of advanced gizmos. There are some basic physics and engineering principles that these people who have been there 25, 30 years know. And that's why I cannot emphasize enough the need for apprenticeship, especially for maintenance. I would also recommend that network operations center people spend some time out in the field. Quite often they will sit just like armchair anthropologists in the 19th century, espousing on Andaman Islanders and the Aborigines and all these people without ever having gone there. Have your network operations center people make field trips, get to know the field service technicians, understand the infrastructure on which they're sitting on. That will make them much better troubleshooters, more compassionate, and also more efficient. So how can GridStar help in this endeavor? Well, in a variety of ways. There are 4 strategic thrusts that I've created in the GridStar initiative. For those of you who are new to the GridStar initiative, we had presentations in the past about it. I am the liaison to the industry for this DOE-funded project. It was about $10 million. $5 million came from DOE and $5 million in cost share. It is located at the Philadelphia Navy Yard, and its purpose was to create a test bed to test out renewable energy, to test out microgrids, to test out all kinds of smart grid technologies from the substation down to the customer prem. We have a full facility with a smart home with solar panels. We have 3 EV chargers, 2 AC chargers, and 1 fast DC charger. We have a 125 kilowatt hour electric storage unit from Solar Grid Storage with certainteed solar panels and Eaton chargers. So we have all the elements, if you may, of a microgrid. It's an unregulated grid. We have a substation with a distribution line coming to our premises, and there are a few administrative buildings that are on the loop also. What this gives us is a very good test bed to test out smart grid applications end-to-end. And why is that important? Because as you test them out, you understand how to maintain them. So what we want to do is provide this facility as a place to come and practice and learn from the experience here to then develop sound maintenance programs, because you have developed the decision trees from the test beds. And that's where both the collaborative research and the specialized projects. The difference is in collaborative research, multiple entities will fund a common project, and in all of these areas that I've written. And in specialized projects, we would do one-on-one with the customer. Certification services. You have all these standards, DNP3, you have Zigbee, you have HomePlug, you have Wi-Fi, you have IEEE 1547, OpenADR, Smart Energy Profile, 1.x, 2.0, all of these standards, the SAE standards, J1772, J2836, 2847, that regulate the communications between the charger and vehicle and so on. All of these standards need to have a test bed in which we can take a vendor product and certify that it is compliant with certain standards. Why is that important? Because the adherence to standards also puts certain limbs on the decision tree for incident response. There are certain specifications in each standard. There are certain ways in which the device has to operate. Developing a robust certification regime allows us to develop these decision trees for you. So in all of these ways, whether it's education and workforce development, collaborative research, specialized projects, and certification services, all of them are going to help you develop a robust maintenance program. What do I mean by robust? Where you have a workforce that understands what they're doing in the least amount of time possible, and the uptime is maximized, and the equipment is used to its max without having to return equipment unnecessarily. So keep all of these things in mind, and as you think about your need to develop maintenance programs and to do research and to learn, look at the GridStar facility in the Philadelphia Navy Yard, and it's gridstarcenter.org is the website. You'll see the courses, you'll see the research areas that we're focused on. And we're trying to initially create a facility for the northeastern region, but we're not limited to that. I mean, there are other universities with other smart grid programs like Illinois Institute of Technology, like UCLA, like UCSD, and we want to be in that family of universities that provide smart grid research and R&D facilities. So with that in mind, I will now move to Q&A and discussion. I will be at the CITER booth number 3621 at DistribuTech next week between Tuesday and Thursday during the exhibit hours. You can ask for me, and my cell number is right there on the slide. If you need to reach me there, text me while you're there. I'll be happy to meet with you over a cup of coffee, talk about maintenance, cybersecurity, information systems, you name it, of all the various topics we've been talking about in the Smart Grid Educational Series. I want to conclude by just simply saying that the educational series is designed to help you think out of the box. And when I say out of the box, I mean out of those electrical systems that you're managing, out of even your organizations. You have to look at where we are headed as an industry. Look at the patterns, look at the clouds that are coming together, and try to figure out how are you going to avoid from getting wet from the storm that I have described. And with that, I will open it for questions, and I appreciate the time that you've given me. So for those of you who would like to ask questions, you can put them in the chat window. Okay, so we have a couple of questions. One is from Paul Heitman, who says, what is your thought on incentives and penalties tied to SLAs? I like them. We are, as Joseph Campbell, the behavioral psychologist, said, we are a shame-based society. So if we are a shame-based society, incentives and penalties are critical to enforcing SLAs. If it's just business as usual and the person says sorry, well, who's going to pay for sorry? So I really believe, just like, you know, when you have a non-disclosure agreement and you seek compensation in case there's breach of confidentiality, the same way, if an SLA breach leads to excessive downtime, which affects the brand or affects the revenue generated by a service provider, definitely. Okay, next question is, what about OTA software upgrades as a maintenance strategy? So, Paul, can you explain to me what OTA is in the chat window so that I can understand what you're referring to? And Murthy Divakaruni says, great presentation, well articulated, thank you. So, Murthy, thank you for that. Let's see what, oh, over the air. Okay. Yes. So, over the air software upgrades have certain prerequisites. And one of the biggest prerequisites is having a broad enough communication channel to carry the software upgrade and not disrupt mission-critical functions. Now, certain types of protocols allow you to have what I would call a supervisory channel in which you can move such files. But if you're going to open it up to the pipe, and the pipe is low power, narrow bandwidth, I would be very, very hesitant and careful about doing such software upgrades. Because if you end up disrupting the mission critical function because you're doing this to save cost of sending someone to do the software upgrade, you end up actually behind, not ahead. So my answer is good strategy with the proper capacity planning. And then next question is Ray Hayes says, note that besides have databases, etc., ready to accept new data, try to have applications to process it in place before it starts flowing in. Otherwise, it is easy to be overwhelmed. Very good point, Ray. And this is part of that Q theory that I was talking about. You know, our Creator has given us that application in our brain. So we know, we don't even think about it. It's there since childhood, that we filter information and parse it and put it away. So what Ray Hayes is talking about to have the applications process it, parse the data, and store it correctly is very, very important. Other questions, comments? We have, let's see. Any other questions from the audience? Okay, so I'll just give people a minute or two, and I will make some of my concluding remarks, because I don't see any. All right. So in conclusion, there are a couple of observations that I wanted to make. One is that please don't make maintenance programs an afterthought. Maintenance programs are critical to the viability of organizations, both those who are receiving the maintenance services as well as those who are providing it. When I say don't make it an afterthought, don't use simple arithmetic to come up with pricing plans. Make sure, if you are the writer of the RFP at a utility, make sure that there is sufficient budget kept to pay for maintenance. On the other side, as a service provider or a vendor, make sure that you are showing enough transparency in the process so that the maintenance programs are articulated properly and communicated to the client so that they can justify it in their budgets. If you don't have a good, robust maintenance program, that downtime is going to get you, because hardware is a fraction of the business cost. Think of it like this. If you had a butchery and you were grinding meat to make ground beef, think about the machine. You buy a machine, it needs to be of a certain quality, you make a certain investment. But compared to the cost of all the meat it's going to process, the machine is not going to cost that much. So it's best that you make a good investment and get a good machine. But maintaining the machine is critical to making money as a butchery, because that ground beef that you're getting is what will generate revenue, not the grinding machine. So this is how you should look at infrastructure, that you should look at robust maintenance programs, because it is the uptime of this infrastructure that's going to generate revenue for you on an ongoing basis. So don't make it an afterthought, put sufficient budget into it, and have transparency in the process. Now we have a question coming from Mike Shea, who says, how would IOUs motivate their workforce to get trained while the workforce are swamped by their daily work? Very good question. And the answer to that lies with the CFO of the utility. The operations people need to sit down with the CFO of a utility, of their own utility, and suggest the following, that tell me, where would you like your utility to be in 10 years, 15 years on the balance sheet? And the CFO will make some observations. Then you bring in the marketing person into the room and say, what markets would you like to be in? And then they'll give you their vision. So somewhere between that perception of a future and where they are today, there's a gap. That gap creates what I call creative tension. And that creative tension is eased by proper training. So then what you do is you create a business plan which you show the CFO and the marketing person, convince them that by making a strategic investment now in adding to the workforce to create some relief time for the existing workforce so they can get trained will allow you to go from point A to point B. Without that vision from the CFO and the VP marketing, and a business plan to get you there. You're not going to get those additional resources to add more people to your workforce, to free up the existing workforce so that they can go and get trained. Because the way it is business as usual today, yes, you're right, Mike Shea. You're not going to get the bandwidth, and what ends up happening is they have to bring very expensive people from outside at the 11th hour who have the training. And by the way, then you know what they do? They end up creating a monopolistic situation where now the utility is beholden to them and has to respond to them because they didn't make the investment, strategic investment, when they needed to. So that is my answer to that question. Any other comments, questions? Anything in the chat window? Nothing in the chat window. Okay, so at this point, I would like to provide some logistical notes. Our next webinar is going to occur sometime in early February. I'm going to provide a speaker and some description of the presentation. I am in the process of getting that finalized. And then there is going to be an in-person seminar on February the 20th, I believe, in Pleasanton, California. And Gary Sorkin from TUV Rhineland is generously offering us his facility to allow me to bring the speaker there for the seminar. And then starting in March, I'm going to look, once Philadelphia's weather improves a little bit. It seems like every time I'm going there, they're having some kind of snowflake demonstration. And it's been very difficult to go there. But I'm looking forward to starting in March, having a monthly seminar out of our smart home from the Philadelphia Navy Yard. And I welcome people who are on the call from that area. Even if you're an hour away, drive over and come meet us, see the facility. It's an exciting experience. And with that, I look forward to seeing all of you at DistribuTech next week. And please come and visit me in booth 3621. And with that, I will now stop the recording. Have a wonderful afternoon, and thank you so much for your time today. I hope that this presentation is valuable to you. It will be sent with the webcast recording by tomorrow. Have a good afternoon. Thank you.